Hello everyone, welcome back. Let's solve the problem. First, missing positive. I hope that most of you are able to solve this problem, but you came to this video because you want to see how to approach this type of problems in an interview. If interviewer throws you this problem, you need to optimize it in every level. So in this problem, we will be discussing every approach we need to follow during an interview. So please watch the video till the end. You will learn many concepts. So first, let's understand the problem. So I am hoping that you have solved it. If you haven't solved, please go and give it a try because it's an easy problem. But the hard tag is because you need to optimize space and time complexity in every approaches. That's why it is mentioned as hard. Now let's see. Given an unsorted integer array numbers, we need to return the smallest positive integer that is not present in nums. He's saying that he is given unsorted integer array. We need to return the smallest integer that is not present in nums. Positive integer is something it will start from 1 to infinity. Positive infinity. It's not 0, right? Not 0 and negatives. From 1 to positive infinity. So whichever the number is minimum and which is not present in the unsorted integer array nums, we will be returning that number. So we must implement the algorithm that runs in order of n time and uses order of 1 auxiliary space. Auxiliary space is something which we are using, not the system. So if you see we are declaring the array, right? If we are declaring the array, so the space is order of n. If you are declaring an array, it will be order of n. Auxiliary space is something which we are using. So you should be solving in order of 1. So extra space you should not take care. You should solve it in order of 1. Now let's see this input 0, 1, 2. So you can see here the numbers in the range 1, 2, 3 are all in the array. So I am returning 3. Here 1, 2 is not there. 2 is not there. So I will be returning 2. Here you can see 1 is not there. I will be returning 1. You will get the doubt. 7, 8, 9, 10. 10 is not there here. But positive integer starts from 1 and it will reach till the positive infinity. So first you need to check 1. Then only you can come and check over 10, right? Those smallest integer 1 is missing. So you can see 10 power 5 and my integers are from minus 10 power 9 to plus 10 power 9, like approximate. So first approach comes to our mind is brute force. So what I will do is first I will take 1. I will iterate from 1 to n. From 1 to n I will iterate. Okay, I will try to iterate from 1 to n and I am going to check. I will be iterating 1 to n and I will be checking my 1 is present in the nums. 1 is present in the nums. So if it is present, then I will check for 2. Then I will check for 3 till my element which is not present. Now at 4, if the element is not present in this nums, then I will return 4. It's simple. Now let's consider this example. First we will be going with 1. 1 is present, right? So it is false. 2 is also present, so it is false. 3 is not present and it is my smallest positive integer, so I will be returning 3. So if you do this, your time complexity will be order of n into n. It will be order of n into n, and this approach you need not to be coded in the interview, because if you code all the approaches, you will be wasting a lot of time. Just you need to explain like how exactly the brute force works. Then you will think, okay, this is the brute force solution. Now interviewer will say, okay, let's optimize more further. Now let's see the first approach using the sets. I have used set here. And I have pushed every element into the set. And I am iterating from 1 to 10,001 because now you can see nums dot length is 10 power 5, right? It is 10 power 5, but my total elements are minus 10 power 9 to 10 power 9. But if my length is 10 power 5, so all my elements are from 1 to 10 power 5. So any element between this only is valid, right? Only this is valid because my total elements are 10 power 5 and 1 to 10 power 5 I will be having all positive integers. If all positive integers 1 to 10 power 5 are present, so my answer will be 10 power 5 plus 1. So I will be iterating 1 to 10 power 5 plus 1. And if my h dot find of I is equals to h dot n, that means I am not encountered that element, so I will be returning I. So I think you have got it. Why we are iterating from 1 to 10 power 5 plus 1? Because this total elements are 10 power 5 total elements are 10 power 5, my positive integers are from 1 to 10 power 5 in the worst case scenario, or else in anywhere it will be missed out. If negative elements or zeros are coming, anywhere it will be a missed out, so that will be my positive integer. So that's why we are iterating here. So here my time complexity will be, you can see here we are using the set, so set will take log n for search, and we are iterating n times, so it will be n into log n, and we are using extra space, so it will be order of n. So interview will ask, try to optimize the space, let's think how you can optimize the space. So to optimize, I need to sort. Okay, I will sort it, and I will use binary search. Oh, that's great. How you are going to use binary search? So first I will sort it. Sort v dot begin comma v dot end, and search I comma v, so it is same 1 to 10 power 5 plus 1, we are going to iterate 1 to 10 power 5 plus 1. Now this is my vector, and in this I will check, this is like if my k is equals to v of I, v of m, that means I have encountered that element, so I will be returning false, that means it will not come into the loop. If my element is not present, then I will be returning true, so I will be returning I. So I think most of you know binary search, how exactly it will work. So first we'll be having 1 to n, first we'll calculate the mid. If my k is greater than v of mid, that means my element is present between mid and n, so my I will be mid plus 1. So from mid plus 1 to n I will be checking. If my k is less than v of mid, my k is definitely present between 1 and mid, so I will neglect mid to n, so it will be like 1 to mid minus 1. So this is the simple binary search we are going to follow. So if you do this, it will be taking n into log n, because inbuilt sorting will be n into log n, and we are not using any extra space, so it will be order of 1. So we have optimized this space, to order of 1. Now let's see some different approach. So which approach you can follow? Now this is some sort of different approach which I thought it will be like a counter. You can think about a sliding window or two pointer. It's mostly a two pointer thing. Now let's see this approach. This is interesting one. First I will sort it. Then if my I is less than n and v of I less than or equals to 0, if it is less than or equals to 0, I will be doing I plus plus. Because I don't require negative elements and zeros. I am neglecting it, so I will be doing I plus plus. If my I reached n, that means my whole array has negative integers and zeros only, so I will be reaching n, so at that time I will be returning 1, because 1 will be my smallest positive integer. Now while I less than n, so if my I is not reached n, so I less than n, and c will be my 1, so c will be my 1. If while I less than n and v of I is equals to, that means if my elements contain 1 1 1 and my c is equals to 1, so this c is equals to 1, but my I will be, it should be equal to this, so it should come here, right? That's why we are using this while loop inside. V of I is equals to c, I am doing I plus plus. If my this I, v of I, and this c also will be incremented to 2. If my next element is 3, that means v of I is not equals to 2, so we will return 2, right? 2 will be my smallest positive integer. So if you see difference between this approach and this approach, here we are doing the binary search, so it will be taking log n extra here, so we have eliminated the log n here. So it will be like same, it will be, we are using sorting, inbuilt sorting, it will be n into log n, but in this it will be order of n only. So overall it will be the same, but we have decreased in this. Now interviewer is still not satisfied with this approach, and is telling that no, I don't want n into log n, I want order of n time. How can you do that? I want order of n only. So let's think how you can come up with the order of n. So you will think and you will say, okay, I will think, and so this is the solution. So I will think and I will try to use scene array for lookup. This is like array for lookup is, I will use scene, and it will be going from total n plus 1 elements will be present in the scene, because as I explained earlier, 1 to 10 power 5 only my elements can be present. In this 10 power 5 plus 1. Only in this range only, I can get the maximum and the minimum positive integer. Now see in n plus 1, and if my n is less than 0 and num is greater than 0, that means from 1 to n. If my 1 to n, if I am seeing any integer, so I am making a scene of num is equals to true. Scene of num is equals to true, and we are iterating through 1 to n, and we are returning the smallest integer. If from 1 to n I am iterating, if I am not able to see any, so that means I have consider n is equals to 10. I have elements 1 to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So till 10, all my elements are seen here. All my elements are seen here. So I need to return 11, right? Directly I need to return 11. So this is the 11. So if 1 to 10 I have elements, but 9th element is missing. 9th element, instead of 9, we have 11 here. 11, right? So in this case, the scene will be negative at this position, because my 9 is not visited. 9 is not visited, it will be like false. All values will be true, only 9 will be false. So it will be false, so we will return 9. So it's simple. Now this is the approach. So if you see this, here my space will be order of n, and here my time will be order of n. So we have decreased the time from n log n to order of n. Okay, we have decreased the time. So interview will say, okay, you have decreased the time and you have decreased the space. Can you decrease the space? Can you decrease the space to order of 1? Can you do this? So it depends whether you have time or not. So you can come till this approach, and next approach, mostly interview will say, yes, you have breakdown into different approaches and you have optimized in a much better way, but still if you have any thoughts, can you optimize it? So in this way you will get, but I think most of you will fail. I was also not able to get the thought of cyclic sorting. So I saw the editorial and I understood myself, and I will try to explain that one. So this is the most difficult thing to come up in an interview, unless and until you know about the cyclic sort. So I will explain what does cyclic sort. Cyclic sort will work when we have a fixed range. From 1 to n only my elements are present, because as I mentioned earlier, from the beginning I am mentioning 1 to 10 power 5 plus 1. Only in this range only my elements will be present, and this is the first thing we need to keep our mind. In our case, we are ignoring zeros and negative numbers. So in our scenario, we are ignoring zeros and negative numbers. Now let's see how the cyclic sort works. Now consider n is equals to 9, and these are all my elements, and our indexes are from 0 to n minus 1. 0 to n minus 1. And when you are encountering negatives or zeros, we will be ignoring it. When you encountered 1, at index 0, if it is 1, you need to go with index 0. If it is 2, you need to go with index 1. If it is n, you need to go with n minus 1. Because this algorithm says that at every index, if you have some elements, this algorithm states that if you have 0, 1, 2, 3, 4, from 0 to it will be like 1, 2, 3, 4, 5, or 0. If you are considering 0, if it should be 0, 1, 2, 3, 4, it should match with every element. Cyclic sort says that it should match with every element. So here we are starting with 1, that's why we are going with n minus 1. If we is saying that we can include 0 as well, you need to make it equal. 0, 0, 1, 1. That is the main thing here. Now here you got 1. At I is equals to 1, you got 1. Now I will say that I will swap with 0. 1 means you need to swap with 0, right? So I will be swapping with 0. Now I has reached my second element, and I need to swap it with 1, right? 2 is 1. I need to swap with 1, 2, and here we have minus 10. Then I got 2, and I will check whether my element here 2 is present or not. Yes, 2 is present, so I will not swap. I will say I will make you same. So it will be same. At I is equals to 4, you can see 3. 3 means at index 3, yes, I can definitely swap. At index 3, my element is not 3, so I can swap it. So here we are swapping it. I is equals to 4, right? I is equals to 4. This is 3. Yeah, this is some mess has happened. When I is equals to 4, we will be having 1, 2. Here it will be 1 2 minus 10 2, and this will be minus 10 only here. It will be minus 10. It will be minus 10. My 3 will be coming here, my 2 will be going here, 2 will be going here. Sorry for that. Now because at 3 this is my index 4, I is equals to 4. Oh, sorry, I is equals to 4 3. That's true. No, sorry, now I confused with this. It I is equals to 4, we have 3, so it should match with 2, right? It should match with 2. That's why we are converting now 0 1 2 3 4 with swapped with second element, so that's why we are getting 3 here. Try to think. So sorry for that confusion, so sometimes it happens. Now at I is equals to 5, at I is equals to 5 we have 4 need to swap with index 3. 4 need to swap with index 3. This is my index 3, so I have swapped with index 3. You can see here 4 minus 10 2, and you can 6 at I is equals to 6. At I is equals to 6 you can see my element is 6, so I need to replace with index 5. I is equals to 6, I need to replace with index 5. Now you can see here 0 1 2 3 4 5 and 6, so we have replaced with index 5. Here at index 5 we got 6, at index 5 we got 6, and we are replaced with this. Now at I is equals to 7, I is equals to 7, it is 7 only, it is 6, and at 6 fifth index I have 6, so I will not do anything, it will be same. At I is equals to 8, that means at 7th index 0 1 2 3 4 5 6 7, at 7th index I will keep 8 and I will swap it with 7th index. So I think you have got it. These are all my elements. So in this algorithm we are matching with every element, right? At 0 1 should be present, at 1 2 should be present. If I will iterate and I will check. If at 4 if my 5 is not present, so I will return directly 5. I will return 5. At 3 if my 4 is not present, I will directly return 4, because 4 has never occurred. So we did not swap, and that will be my first missing positive integer. So if you can see here, I will iterate and I will check. At index 0 1 is there, 1 2 is there, 2 3 is there, 3 4 is there, but at 4 I don't have 5, right? I don't have 5, so I will returning 5. So this is simplest algorithm. So I was a bit confused in between because of that variables. So this is the approach which I have copied from the editorial. Use cyclic sort to place positive elements smaller than n at correct index. So you can see here, if my nums are greater than 0 and nums is less than or equals to 1, and my nums of I not equals to nums of I minus 1, that means now if you see here at this, after this sixth element has placed at index 5, and one more 6 you got, and you should not replace it, right? It is element is already present, so I will not swap. This is the new condition we need to add, and we need to swap it. If my conditions are matching, I need to swap with nums of I comma with that index, nums of I minus 1. That means we are at 4. If you are at 4, you need to swap with 3. If you are at 6, you need to swap with 5. That is the main thing we are doing here. Now we return to the nums and return the smallest missing positive integer. We will check nums of I not equals to I plus 1, return I plus 1. You can see the cyclic sort, 0 1 2 1 2 2 3 3 4 is not matching, so we will return 4. If it is matching, 3 4 4 5 5 is not matching, we will return 5, so we will return I plus 1. And if all elements are matching, if my elements are n is equals to 5 and all my elements are present 4 5, so every element is visited, so I will be returning 6. If you see here, the time complexity will be order of n, and my space will be constant. It will be order of 1, and we have satisfied the required criteria. And you can see the editorial. In editorial he has mentioned you need to ask the interviewer. This approach modifies the input. It changes the order of nums but not the values of nums. Order will be changed. In place algorithm overrides the input to save space, but sometimes this causes a problem. We need to check with the interviewer before modifying the input. It's better to check with the interviewer. So go with the editorial, read that as well. Read the understand this approach, and you are well and good for the interviews for this type of problems. So I think you learned something new from this video. In the middle I got fumbled a couple of times because this is the new concept which I learned today. So if you are new to the channel, please do subscribe, and every day I will be posting the videos. So you can subscribe it, and I have created a WhatsApp community. You can join there for better discussions, and if you have any doubts or any concerns, you can comment it down. I will help you. Thank you. I will see you.